Okay, so let's keep going with our quantitative reasoning. Just as a reminder, we're looking at this situation associated with an object moving back and forth, back and forth. Now, in order to analyze this, we actually started off and we already made a sample position time graph to go along with this, just as a way for us to analyze. So we can actually use that as we're going through. And we know that the period is 2. We already stated that. And I'm going to actually write down my equation here just so I don't forget what it is. 0.2 meters times the sine of 2 pi over 2 times t. And we already decided what each of those pieces meant. So I have a period of 2. So then I'm going to go through and I'm going to say, well then, half my period has to occur at 1. I know my maximum is at 0.2. Negative 0.2. So then I'm set. That's a terrible graph, but that's okay. Alright, so then how do we move from position to velocity? Well, the first thing I need to figure out is, how do I go and use a position time graph to get to a velocity time graph? Well, the easiest thing to say is that I would use slope. And as I look at the beginning here, I have a maximum velocity slope at the beginning, maximum positive. So I know my velocity is going to start at maximum positive. And I know it's going to end at maximum positive. So then the question is, when is it 0? Well, it looks like if I were to draw a tangent line at that point, it would be 0. So that's my 0. It looks like if I draw a tangent line at that point, that's my maximum negative. Maximum negative. It looks like if I draw a tangent line at that point, again, I'm at 0. So what I get is a graph that looks like that. Now that's a cosine graph. So I already know right off the bat that this is going to be cosine based. Okay. Now let's look at acceleration. With an acceleration graph, remember I'm looking at slope of my velocity versus time graph. So let's start off at the beginning. This has a slope of 0, which means I have an acceleration of 0 at the beginning. Then it goes to a negative slope. Maximum negative slope occurs there. 0 slope, again. Maximum positive slope occurs in the middle. And then again, 0. And this should be the opposite of my position time graph, because I know that in order to be in simple harmonic motion, those are opposites. And that's true. So it works out nicely. So there's my graphs. Now, notice I haven't labeled anything on my velocity time or acceleration time graphs just yet. In order to do that, I need to remember situations associated with my equation. Just a quick review as we look through, because I'm going to have to write my velocity and my acceleration as a function of time. As I'm going from position to velocity, what I'm doing essentially, those of you that are calculus based, is I'm taking the derivative of this function. When I do that, I get an equation that looks like that. So what this tells me is if this is my maximum position from 0, then this has to be my maximum velocity from 0, based on how these functions line up. And I can continue it one more. I can go all the way down to acceleration, where I would get omega squared, take out another omega, a sine of omega t. In this case, this one is negative. But then this would be my maximum acceleration. So when I'm writing out my velocity versus time equation, I'm going to say my velocity equals, well, 2 pi over 2 times 0.2 times the cosine of 2 pi over 2 times t. Now there's a way to simplify that. Essentially take pi times 0.2 and get 0.628. So when I do that, 0.628, notice here, this is in radians, 2 pi is in radians, 2 is in seconds, so meters per second is what I get. That totally makes sense. Times the cosine of 2 pi over 2 times t. So there's my velocity as a function of time equation. And what I can do from there then is I can say, oh, my maximum velocity is 0.628. I'm going to go put that on my graph. 0.628. And down here, 0.628. Because now I know what my maximum velocity is. And I can take it a step further and go with my acceleration as well. So my acceleration is negative. Now omega squared is 2 pi over 2 squared times 0.2 times the sine of, again, omega t. So 2 pi over 2 squared. So pi squared times 0.2 gives us an acceleration of 1.97. So I know that I get negative 1.97. Now again, let's look at the units. Radians squared over seconds squared times meters gives us meters per second squared. Perfect, that's our acceleration. Times the sine of omega t. So there's our equation. And again, we can go in and write our maximums based on what we know about our situation. Now, a couple of things come out of this. One, I know that my maximum velocity then is always going to be given by omega times a. I know my maximum acceleration is always going to be given by omega squared times a. Well, and that's just magnitude, right? Its directionality will be based on this sine function or this cosine function. But that's how I can figure out what my maximums are. My maximum position is just a. Okay, and then we go from there.